Uh, hello, world. Hello, world is probably the first word string program that every person will produce that starts to learn how to program. So I'd like to borrow this phrase to welcome you, everyone, in the audience for taking your time to join me today in Taiwan Chang's webinar. For housekeeping notice, if you come across any questions at any time during the talk, please type in the chat box to allow us to collect your questions. Or if it's not now, you're absolutely welcome to send us email with questions or comments after the call. Our topic for today is about a newly amendment chapter for software. Just an intro to the architecture of the document. TIPO has only one pile of patent examination guidelines, but there are several parts and more than 20 chapters in it. And the first part is about procedural instructions. The second part is about invention patents practices, where the first several chapters of it govern the basic universal requirements like novelty, inventive step, disclosure support, etc., for all kinds of technological fields of inventions. And then going down in the second part, there's a chapter dedicated to software inventions, and there are more specific applied rules about patentability that should prevail if the universal requirement does not apply. Our topic today focuses on this chapter's amendment, which is effective now, and we're not going to divert too much of attention or time on the universal basics of all inventions, though. Part of the reason for this chapter amendment is that TIPO found there have been more and more different variations of software-related applications in recent years. And also came to word that other peer offices already undertaken similar plans to change their guidelines. So they collect the cases and conduct some researches to produce statistics and sum up to some conclusions which drove them to amend the examination guidelines in hope that it will keep up with the filing trends. So the first part of the presentation is the filing stats. The second, the third, and fourth part are the three major aspects in this amendment regarding subject matter eligibility, inventive step factors, as well as some requirements in specs or claims, such as enablement and support. The last part will be my summarized message for you to take home. In 2018, there are more than 1,500 AI-related applications. Filers from Taiwan accounted for most of the cases. US, China come to second and third part respectively. Hong Kong is fourth, you can see from the bar chart. But normally, Hong Kong is not a top source of original patent applications. But here, Hong Kong application mostly filed by the company called Alibaba, which is a Chinese mainland-based business, but registered Hong Kong. So TIPO made a separate bar simply because the ease of sorting based on different jurisdictions of case origin. There are 9 AI functional application first-tier categories based on WIPO classification. TIPO received applications that were able to be sorted in all that 9 categories, but with a drastically different case count from one to another. Majority of cases fall in the categories of computer vision, predictive analytics, and control methods. In the examination of applications, it has been found that more rejections occur in novelty and inventive step rather than subject matter and other grounds. And in fact, subject matter is a requirement that TIPO rejected the least. A core message from this slide I would like to deliver is that historically in Taiwan, the examiner is likely not giving the applicant a hard time in the stage of subject matter, but it can be relatively more challenging gradually when it comes to like novelty or inventive step. And even though this slide does not have a number from 2020 and beyond, but I believe that different level of difficulty remain quite true even now. Okay, now we moved on to the chapter amendment and see what is exactly new. Patentable subject matter is a major point of change by introducing a new flowchart. In this two-step chart to determine eligibility, the first inquiry to ask is whether the software invention obviously a patentable subject matter. If the invention is one of the two types, as you can see indicated in the green route, like number one, involves specific execution of a control to a machine or execution of the processing associated with that control to the machine. Or number two, involves specific execution of the information processing based on the scientific property of an object. Then it is considered a patentable subject matter. But when you look at the orange route on the right, if it's either like not involved, invention not involved laws of nature, invention not involved in technical concept, then the answer would be obviously no, then it is not a patentable subject matter. If the examiner cannot tell whether invention is obviously patentable or not, according to the green and orange routes, then it has to move on to the second inquiry, asking if the invention's information processing of computer software is realized by the use of hardware. If yes, then the invention will be considered an eligible subject matter. In the context of not a general software, but more specifically in artificial intelligence, the inquiry is then particularly referred to like this figure. The cases categorized for obviously yes would be like one, the invention involves the use of AI to control a machine, or the use of AI to perform specific processing over technical information. The case category for obviously no would be like the invention's only manual methods for training neural networks. The invention is only manual methods for adjusting parameters. Or number three, the invention involves mathematical models or just simply the data sets per se. The second step of the inquiry would be like asking whether information processing is performed by the use of AI. Okay, we're going to look at several examples from the new chapters to help you understand the flowchart better. Here are two cases that are a type of obviously yes, but they are specific execution of a control to a machine or processing associated with that control. Case number one is about an automatic rice cooker. The new chapter explained is that the claim invention is to manipulate the function of a home appliance, meaning to control a cooker to finish cooking in a set time. It suggests that it refers to a control of a machine based on the internal components, gadgets of it, etc. So it is to specific execution of a controlled machine in order for it to pass the step one of the flow chart. Case number two is about an on-man and automatic product delivery method. The new chapter explained this, that the claim invention is based on the instructions of a management server, and it has in the claim, using the related action of an X device and a drone and other machines in that claim to accomplish the mission of delivering products. So it is an integrated control of system, including multiple related machines. Now, here are another pair of cases for specific execution of information processing based on the scientific property of an object. Now, the case on the left, case one, is about analytical method for ECG, which you can see the picture at the bottom. It's a medical test that detects heart problems by measuring the electrical activity generated by heart as a contract, as a bond. This claim has several steps of conversions of cardiac signals into this QRS complex X, and then passing the complexes through a specific filter, and then obtaining an output value. Clearly, the claim invention is to perform computation or processing of numerical information of an object's scientific property, which is the electrocardic activities here. Therefore, you would be considered, obviously, yes, patentable. Case number 2 on the right is about a computer program product to detect and prevent card accident. Basically, this claim invention is about a collection and manipulations of information for relative speeds of cards and generate a result that whether an accident occurs. So it is kind of an information processing according to an object's physical property, which means the speeds of vehicles. Here, to generalize a bit, the scientific or technical property referred here ranges from like physicals, chemicals, biological, electrical properties, and others. Specifically, it can be anything like engine rotational speed, genetic sequence, and the associated protein expression in the biological field, or chemical bonding of elements in chemistry. Again, but back to the flow chart. If the examiner cannot tell if an invention is obviously patentable or not, then you have to continue on to the second inquiry, asking, is the information processing of computer software been realized by the use of hardware? Essentially, ask the examiner to look up for 2 elements. The first element is if there is a technical means or steps of synergistic operation of the claim software and hardware. In the course of doing so, there are some key points to note. The hardware does not have to be a particular like top-notch device. It is absolutely okay if it's only using an entry-level PC. If there is only the purpose or result of the information processing, but there's no like specific technical means being provided, then you're not going to fulfill this inquiry. And likewise, if it's having hardware without technical means or step for synergistic operation, you're not going to fulfill this inquiry either. The second element to look up for is if the information processing or computations accomplished according to the specific purpose of the process. Things to know in this factor are that the purpose is quite pivotal for you to identify the technical means as claimed. Besides, if you only present information collections, input, output, demonstration of data, then it's often considered an inconsequential step. When we say hardware under this context, we refer to anything from like the very basic computers or central processing units, CPUs, or like memories, or even just a keyboard, very normal keyboards or monitor. Again, here we look at the 2 cases. One is good and the other is not good. For case number 1 is a computer system which has 3 units arranged side by side, and each has its own independent functionality, but does not present any specific technical means or step for a coordinated operation of computer software and hardware. Of course, this is manifestly a very bad example. I don't think any of our clients or any one of you in the audience would ever make such a claim set. Case number 2, it is the computer program product loaded into a computer to generate a text. So it presents a computer physically. Based on the general knowledge, the examiner will be able to imagine there is a synergistic operation of the loaded software and its inherent hardware in that computer, like CPUs or memories or other chipsets. And they will help realize the technical means and information processing to generate a text. What is more than that is there is a clear step-by-step method to meet the purpose of generating a text. It presents a specific information processing method, and therefore it passes the second inquiry of the test. Third part of the presentation is about factors to inventive step. Before I'm telling you what is new, I have to step back a bit to highlight Taiwan's approach to establish inventive step from the general principle of the examination guidelines. It is somewhat like the grand task from the USA. First, you have to determine the scope of the invention, and then you determine the content of prior art. And thirdly, you ascertain the ordinary skill of the person having ordinary skill in the art. Then you resolve the difference between the prior and the invention. And finally, you're able to decide if it is easy to accomplish the claim invention based on the general knowledge and the prior references. Specifically, in this fifth step, the examiner will cross-investigate any factors to encourage or discourage inventive step. The new chapter had some changes over the discouraging factors, and more particularly on the what they call the motivations to combine references and simple variations. Because they have been commonly seen in software and AI patent applications in Taiwan. Motivation to combine prior references is a discouraging factor. It can be that the references have commonality of problem to be solved. In the first case, the claim invention is a method of conducting market research analysis using a computer. And the primary reference is a method of using a computer to process a series of surveys. And the auxiliary reference is a method for designing a market survey questionnaire. Now, in this case, a FOSITA in the software field would have easily known the claim invention by replacing human labors by a computer to perform market research and analysis questionnaires. And therefore, the problem to be solved according to two references have commonalities. And therefore, there is a motivation to combine the two references. Motivation to combine prior references may happen when the references have commonality of functions or effect. In the case on the right, the claim invention uses a trained convolutional neural network model to predict the weldability of steel plates. Now, weldability refers to the ability of a metal to join another metal in the presence of heat. The primary reference is about the use of mathematical model to predict weldability. And the second reference is about the use of convolutional neural network model to predict glass quality. Well, the teachings in the two references have commonality in the functions or effect of using models to predict the properties of materials. And therefore, there is a motivation to combine these references. Simple variations. Simple variations also another inventive step discouraging factor that have been often seen in software and AI inventions in Taiwan. The first type of this can be if the common knowledge is reproduced in a computerized virtual space or is a combination of virtual and real environment, then the invention is considered being able to complete by simple using the regular system analysis. Example of on the left, which is a tennis game device. The distinguishable feature in this invention is only the different speed set based on different materials of tennis court surfaces. But the scientific facts that hard surfaces absorb more kinetic energy, whereas soft surfaces absorb less kinetic energy is a common knowledge in the field of physics. So including a feature of different ball speed in the claim is just a simple variation. It does not help the claim to have inventive step over the prior art. Example on the right, if use of computer system in one field to another, while only the data to be processed is different, then it is considered simple variation. It is in this very straightforward case, the only difference is the information to be searched. One is used to general products and the other is used for medical information. For different search environment situations, FOSITA will be able to transfer the prior system to product searches. the claim invention, just a simple variation to undermine the inventive step. There are two more types: the adaptation of software based on common knowledge, which is on the left, and the addition of non-technical feature, which is on the right. Essentially, in the case on the left, when you only incorporate a business method, which is cooling off period, for people who to exchange or return products within a period of time after their purchases, and put this method into an online shopping system like this, and it is only introducing common knowledge, wouldn't help. For the case on the right, the only feature is to change the style of the clock from the digital form to an analog form. It is apparently produces no technical outcomes, so it is just a simple variation. Okay, now we're moving on to the fourth part of the presentation, changes being made for regulations about specs and claims. Fundamentally, the statutory rules for enablement can be found in Article 26(1) of the Patent Act. Now, in the patent examination guidelines, if there are any particular technical solution to achieve a technical function, they should all be included. Anything such as the algorithms, necessary flowcharts, block diagrams, pseudocodes, sequence diagrams, snippets, etc. The new chapter further tells us that if an invention is made by means of specific software hardware, such as programming languages, functional libraries, integrated development environments, the IDE, software development kits, the SDKs, databases, neural network models, and etc., they all should be included to be disclosed in the specification, no matter it's either commercial or open source tool. For example, if an invention is made by a commercial chip and associated development software package, the spec should disclose the product name and the model of that chip, and the name and the version of the development package, as well as other information necessary to enable the invention. Claims. The old chapter has exemplified some typical preambles for you to claim. If you claim an apparatus, the new chapter re-emphasized that not all limitation has to be structural. It can be functional as well. But this is not new. It's just an emphasis of what's already been in practice for a while. Furthermore, if a data structured product was affirmed in this new chapter to be in eligible categories, alongside with the traditional device or systems, computer readable medium, or a computer program product. A typical example of a data structure would be like this, as shown in the slide. Please note that these are the categories of claimable subject matters, but it does not mean you have to strictly claim a preamble literally the same as the wording of one of the categories. Other eligible preambles can be like programming models, libraries, support vector machines, neural networks, neural network models, etc., as long as they are considered to be one of the main categories. And most importantly, it passes the new flowchart as we explained in the first part of the presentation. A claim must find the proper support in the spec. The statutory rule for support can be found in Article 26(2) of the Patent Act. As you read, each claim should be disclosed in a clear and concise manner and be supported by the description. A new benchmark of description support is added for software invention. It says that even the claim invention can be implemented by an approach in the description. However, it is yet considered not sufficient support to the claim if, number one, a facilitator would not know that there are alternative approaches that not disclosed in the description to achieve the claim invention. Or number two, a facilitator has good reason to believe that the specifically disclosed approach in the description cannot achieve the claim invention. Okay, this is my last page, a summary of what we went through for today. Number one, statistically in Taiwan, subject matter is an easier requirement, relatively easier requirement. The least number of rejection cases may explain for itself. Well, as in contrast with the inventive step, which is oftentimes relatively more challenging. Number two, a new flow chart to determine subject matter eligibility was introduced. Remember, there are two steps. If the invention is obviously a type of patentable invention, after the first step, it passes the test. Or to the contrary, if it is obviously not a type of patentable invention, then you'll be kicked out without a bother to go to the next step. Number three, claimable subject matter ranges from tangible computer readable mediums and devices to any intangible methods, systems, computer program products, data structures, etc. Motivation to combine references and simple variations are two negative factors to undermine inventive step. Number five, the new chapter emphasized that any specific software or hardware tools used to achieve the invention, regardless if it's commercial or open source tool, should be all inclusive in that disclosure. Okay, that's all I wish to deliver for today. I think we still have some time. I'd like to answer at least one question that we received before the webinar from a member in the audience, who is also a good friend of ours. Let me read this question verbatim. Could you comment on the patentability of AI or machine learning ML inventions, where the AI ML part has not been created by the applicant, but is, for example, a publicly available open source tool? The invention is then in the selection of the input to that AI tool. If my understanding to this question is correct, generally, if the novel feature of the method claim, let's suppose you have word claim and method. In that method claim, it's the novel feature is a step of making a selection or selection of data to feed a non-artificial intelligence. I think it would not by default to make the entire claim ineligible for a patent. Our experience, we sometimes work on the cases where the claim includes something like, as I try to simplify the phrasing, like inputting a piece of data to a mechanism according to a specific condition, or it can be like setting a pair of parameters. These wordings, they all imply an activity of selection or making a choice, and I don't think they are fine. Even in some other cases, we see in the word of selection straight, which is also okay in some cases. So our experience is that it really depends on how we draft the claim language and the drafting skill to try to dilute the dominance of human involvement in that particular selection step. And whether the method claim as a whole is eligible for patent, relies on, as was said in the previous slides about the new flowchart, whether it involves information processing or control of a machine using an artificial intelligence. And I hope that answered these questions. Let me take a look if there's other questions in the chat box. Okay, if there's any questions right now, it is also fine. And we actually hit the 30 minutes time mark. But again, if I highly welcome you to give us any kind of a comment or question that you have after this session by sending us emails or give us a message through our LinkedIn page. But before we officially end, I would like to tell you that we have more webinar presentations coming up, although we did not yet set it as a periodic event, but they are tentatively scheduled in our annual plan already. So please follow us on our LinkedIn page or subscribe our newsletter to receive the most up-to-date notifications and IP news. I wish you a good weekend ahead. Thank you again. Goodbye.